we're going to look at is this one, and here we have a figure with O at the center. So we've got a whole circle, O's right here at the center. We've got that lines AC and BD are parallel. So here's line AC, and it is parallel to line BD. And I would definitely suggest always on geometric figures drawing in what you're given so that you've got it right there in the figure that you can look at then. We have the arcs AC, so this arc and this arc, so BC, together represent half of the circumference. So that makes sense. I've got a diameter going right through, and that's going to be half of the circumference. Then given the angle A is equal to 43 degrees, what is the value of X? So here, if each of these are half of the circumference, so basically I know that I can use either some sort of transversals and parallel lines. So I have parallel lines, transversals are always going to be an option. I also have some shapes in here. So I've got two triangles. That could be useful. Technically this one right here too is also a transversal, right? B to A. I've got these triangles, I've also got the whole thing, so I've got arcs, and I've got an intersection actually. So DC and AB intersect right here, which means that I have vertical angles. So whenever we're looking at a problem like this, which has lots of information and lots of different things going on, we sort of want to see what all of our options are for dealing with the shape right away so that we can then come up with a plan. So the thing right now that might be helpful is to just deal with parallel lines and transversals. Those ones are always sort of fun on here. So I know that if AB is transversing these two, then these two opposite interior angles should be equal. So I can go ahead and write 43 in, and that's sort of satisfying to at least get one angle down on the shape. I also am going to know that these two are equal because they are also opposite interior angles, but I don't have a number for them yet, so that actually isn't super helpful to me. The other thing that I have is that this angle has to equal this angle. And from there, I can deduce that if these two are each 1/4 of the circumference, so if this one's 1/4 and this one's 1/4, I have quarter circles here, which means that these should actually each be 90 degrees. So once I know that this one's 90 degrees and then this one's 90 degrees, I now have two numbers in each of my triangles, and that will allow me to figure out the other angle's value because I have that in any triangle, all of the angles add up to 180. So 43 plus 90 plus, I can just call this blue angle, plus blue equals 180. So here I have 133 plus B equals 180, or B equals 47. So once I know this blue angle, then look, I have another intersection. So I can figure out exactly what X is, and it's equal to this blue angle. So this is equal to X. The other thing that I could have done once I have one 90-degree angle in a triangle is I know that the other two are going to add up to be 90. So in any 90-degree angle, the two angles that are the acute angles that are less than 90 degrees are complementary. So here, 90 minus 43 would be b, and that's equal to x. So it's a quick solve once we get to that point. But there are definitely lots of different things going on with the angles here, which is good to see because we always have lots of different options. We have intersections, we have parallel lines, we have specific shapes, we have inscribed angles. So once I knew this was 1/4 of the circle, I could have said, okay, that means that this outside is going to be 90 degrees also. And then from there, if I have an angle that starts at the center point that inscribes those, it should be exactly equal. So we have lots of different options here, and we just want to make sure that we're going about finding our angle in a way that's taking advantage of what's going on and that's linear. So definitely continue to look at angle questions, but know that they are going to be relatively easy on the SAT, so you should just have fun with them. I hope you enjoyed this video as much as I did, and thank you again for tuning in to this session of the SAT Math on Educator.com.